In this video, I will explain the Haber process. The Haber process is an industrial process in which nitrogen and hydrogen gases react together to give ammonia and heat. Ammonia is important because it's used to produce fertilizers, and fertilizers are important for the healthy growth of plants. In this process, nitrogen is easy to get because 78% of air is composed of nitrogen, and the hydrogen is obtained from natural gases like hydrocarbon and methane. In this process, it's important to notice that this is a reversible reaction where the product, which is ammonia, will dissociate back to give you the nitrogen and hydrogen. Also, as it produces heat, that means the forward reaction is an exothermic reaction, and that means also that the reversible reaction is an endothermic reaction. There are unoptimized conditions for this process, which are 450 degrees, 200 atmosphere pressure, and the use of iron catalyst. So let's have a look at the stages of the Haber process. First of all, nitrogen and hydrogen are fed through the pipes where they go through a compressor. The pressure is increased to 200 atmosphere and the nitrogen and hydrogen are allowed in where they are heated to 450 degrees and then they go through the reacting chamber where there is an iron catalyst bed. The hydrogen and nitrogen will react together to give the ammonia, but this is a reversible process. That means that the ammonia also will dissociate to give hydrogen and nitrogen. So all the three components will always be there. There is a dynamic equilibrium between the three components, the reactant and the product. So to separate the ammonia from the hydrogen and nitrogen, they are allowed to go through a cooling tank where ammonia has a low boiling point, so in the cooling tank, ammonia can be liquefied and then it will be going out and it can be used to make the fertilizers. However, the hydrogen and nitrogen will stay as gases as they have high boiling points and then they will be recycled back into the process where they can be used continuously to make ammonia. So looking at this process, we said it's a reversible reaction and you need to balance or find the optimum conditions for the reaction. The optimum conditions or the conditions that are used will affect the yield, the rate of the reaction, and the cost. So the first factor that we need to look at is the temperature. What would be the optimum temperature for the process? This is an exothermic reaction, which means if the temperature is lowered, then for an exothermic reaction, the reaction will be pushed toward the exothermic route, which means the equilibrium will be towards the right-hand side of the equation, so that will mean increasing the yield. However, lower temperature will also reduce the rate of the reaction because that means the particles, the reacting particles, will have less energy to achieve the minimum rate of the reaction or to have the activation energy. However, if we increase the temperature, that will lead to a decrease in the yield because the reaction now will be pushed toward the left-hand side where there is more of the reactant than the product, but higher temperature will increase the rate of the reaction and also will increase the cost of the whole process. So to balance all of these factors, the optimum temperature for the reaction is 450 degrees. Well, there is a balance between a good yield and a good rate of the reaction, in addition to a reasonable cost. The second factor here is the pressure. Again, this is a reversible reaction. And in this reversible reaction, we can see that there are two molecules of the products are produced when four molecules of the reactant are reacting. So if we increase the pressure, According to Le Chatelier principle, the reaction will push itself toward the side where there is a lower number of particles or a lower number of molecules. That means it will be pushed toward the product. That means there will be an increase in the yield. At the same time, increasing pressure will mean increase in the rate of the reaction because higher pressure means that we have the same number of molecules knocking about each other in a smaller volume. But also increasing pressure will increase the cost of the whole process and have an issue with the safety as well. So if something goes wrong with high pressure, the safety implication will be high. So to balance all of these and to find the optimum pressure for the process, the pressure is kept at 200 atmosphere. And finally, the use of the catalyst. The catalyst will increase the rate of the reaction, but it will increase the rate of the forward and the backward and the reverse reaction at the same rate. So the catalyst will not affect the yield of the product because it will not affect the balance or will not affect the equilibrium for this reaction, the equilibrium position. It will stay exactly the same. So using catalyst will not affect the yield. However, the use of the catalyst will increase the rate of the reaction because it will allow the use of lower temperature. It will allow the different reacting species to reach the minimum activation energy with lower temperature. So use of the catalyst will in the Haber process means that lower temperature can be used whilst keeping the rate of the reaction high. A lower temperature will keep the yield high as well. So this is how the use of the catalyst can affect the yield through the allowing the lower temperature to be used.